let us discuss about a data structure called a stack. Stack, it's a well-known concept. Knowingly or unknowingly, we'll be using a stacks data structure in our daily life. So one of the good example of stack data structure is CD cover. CD cover. So you might have seen those days the CDs were kept in a cover like this, where there will be a spindle. There will be a spindle, and we will continue to keep our CDs into this. Like this, we continue to keep the CDs. And if you want to take the last CD, okay, so what do? You cannot directly take this CD out. Instead, what we have to do? First, we have to remove the recently entered CD, and then the next one. Finally, only you can reach to the last CD and we can make use of it. So the stack is basically, it follows LIFO, last in, first out working principle. Last in, first out working principle. And also we can access to the recently accessed data only. So that's basically the operation of the stack. So now the list of elements in which an element may be inserted or deleted only at the top. So we can access only at the top end of the stack, either for addition or for deletion. We can use only the top end. And there are two important operations related to stack. One is called push operation. Push is nothing but inserting an element. Inserting an element. It's nothing, even in this CD cover, if you take, adding a CD into this CD cover, it's nothing but a push operation. And the next one is called a pop. Pop is basically referred to deleting an element from a stack. So in this example, again, if you look into it, taking the CD out of this disk, out of this CD cover, then that is called deleting an element, and also be called as a pop operation. So these are the two basic operations that we have related to the stack. What are the operations? Push and pop operations. Okay. Now, then the stacks are generally used in an applications where we postpone our decisions for some purpose. So that also basically indicates the order of processing data. So that's I told you, you cannot access the last data immediately unless until we remove all the data from the top. So that basically indicates the order of processing data. That's called a postponing decision applications. In such applications, we can use the stack data structure. The stack can be represented by using an array. So simple array, you know how the arrays are defined. So we can visualize an array like this. A rectangular box has many sections in it, and this is what we call it as an array. And it's as usual, it starts from 0 and goes with the n minus 1 size, and we can store the values into it, and we can access by specifying the array values. So that by specifying the index, we can easily access the value from the particular location. So that's the array. Now this array itself can also be used to implement a stack. So now here, if you look into it, so array representation of stack. Now the same array only, we are going to configure it as a stack. You know what is a stack? It uses the LIFO principle, and we can access only at the top of the stack. Okay. Now let us see that how this is happening here. So we use a linear array called a stack for our explanation. So the stack is going to be maintained in the form of a linear array, and will have a pointer. We'll have a pointer here called top. So this top pointer, what it will basically a pointer variable, and that basically represents the location of the top element of the stack. Top element of the stack. What is the element that's recently added into the stack? And if the top element, the top pointer is equal to 0 and a null, that means it's not pointing anywhere, then it means that the stack is empty. Stack is empty because the value always will be loaded onto the top only. Then also there's another pointer variable here, which is called a maximum stack, which indicates that what is the maximum number that can be held by the stack, or what is the maximum number of the locations can be used by this particular stack. So we are using a linear array and by using 2 pointers. So you can see that here, this is the stack representation using a linear array. So it looks like an array only, where you have an index 1, 2, 3, 4 up to 8. So 1 to 8 indexes are there. And now here, initially, the stack, the top will be equal to 0. Top will be equal to 0. Then once the value is pushed into the first location, the top will become 1. Then in order to store the next value, the top will be increased to 2, and correspondingly the y value will be entered here. Then by incrementing the top, it becomes 3, and to this position, the new value will be loaded. So currently you see that currently if you look into it, the top is having a value 3. So that's a top pointer. And next what we have is called a maximum stack. So maximum stack is just an indication, no? It's a variable which holds the size of the stack, we can say. Holds the size of the stack. Okay. Then the operating procedure for a push. How do we implement a push operations in a stack? It's very important to discuss. First, what we have to do before we push, yes, we need to push for what? For entering the value into the stack, we have to push the value. But before we push the value, we need to ensure that the stack can accommodate a data. Okay, so first what we do, we test whether there is a room in the stack for the new item. Then only what we can implement the push operation. If there is no room, that means the stack is overflowing. There's no room, the stack is overflowing. That means we have reached the top is equal to the maximum stack pointer value. Okay, so now to develop an algorithm for this push operation, so push is a function which is a function of a stack. What is a stack? It's a linear array here, and the top pointer, then maximum stack variable, and also an item to be pushed into the stack. Okay, so now here, so first step while implementing the push is what? Check whether stack is already filled. Stack is already filled. How do you check the stack condition, whether it's already filled or not? By checking the maximum stack. By checking the maximum stack, we will get to know whether the stack is already filled with the values or not. Then what we do, we print overflow on the screen and we return from the program. So that means this condition is going to be satisfied if the stack is overflown. Okay, else what we do, if the else means what? It has it has some room for storing a new value. So what we do, we increment the top pointer by 1. So before we store the value, we always increment the top pointer by 1. So top is basically a location pointer. So we increment the top pointer by, so it will point to the adjacent to the next location. So top plus 1, it will increment. Then the new value to be loaded is there in the item. It's there in the item, and this value will be loaded here onto the screen. Okay. Now here we can see that it can be stored here in the incrementing the pointer first. After incrementing the pointer, what do? We store the item. That also we discussed. Where we store the item? We store the item in the place where the top is pointing. So to the stack of top. Stack of top. So this is basically an array. This is basically an array. If you look into it, so you will have an array like this, and each element of an array, it's pointed by the top only, pointed by the top. So when you say stack of top, what is stack? Stack is nothing but the name of the array. Stack is nothing but the name of an array. So where we use the top pointer to store the value. So the item, new item, whatever is there, that will be loaded onto stack of top. Okay. So finally, then we can return from the program. So that's how basically the push operation is going to be implemented. The next one is called what? Pop operation. How a pop operation will be implemented? It's a reverse one. So first what we have to do, first we have to check whether at least some values are there onto the stack. Values are there on the stack. So test whether there is an element in the stack to be deleted. If there is no element, then we can say it's underflow. Understand? So what we can do when there's no element, it's called an underflow condition. So upon underflowing condition, we cannot pop up any value from the stack. So we can just return from the program. So pop is a function again, which is basically a function of the stack. What is the stack? Stack is a linear array. Top is a pointer, and item now it's a variable where we are going to load the value which we take out of the stack. So first we check in the condition stack has any item to be removed. Okay. So how do we check it here? If top is equal to 0, this condition is important. How do we check in the pop condition for overflowing whether top is equal to max stack? But now here what do? We check whether top is equal to 0. If top is equal to 0, then we'll just declare on the screen, or we can understand the condition. It's an underflow condition and return. Then else means what? Okay, else means what? If top is having some valid values, then first we take the value from where? As usual, from the stack of top. From the stack of top, we take the value. So once again, if you show it in the form of an array, it's going to be an array, and now the top is pointing somewhere. So, and this array is called stack. So the stack of top. So from this location, the value will be taken. And where it will be loaded? It will be loaded onto the item. We loaded onto the item. What do we have to do next? So when you remove it, then what do? We have to decrement the top pointer by 1. So we set the top is equal to top minus 1 in order to decrement the top by 1 from the current value. Then finally we can return from the program. So this is the pop instruction. So these are the two important operations that we perform on the stack. One is called a push operation, other is called a pop operation. In a push operation, we check for the overflow condition. In the pop operation, we check for the underflow condition. Okay, let's see how to implement the stack using an array using a simple C program. So here in the first set, what we have is the push and pop functions, implementation of push and pop functions. And here, just for our convenience, we defined a constant like here max 15. So wherever I use max in the program, it's going to carry the value 15. Okay. So push operation, as we discussed earlier, it's a function of the stack, top pointer, and the value. Okay. So now here you see that here there is different concepts are used here. So let's say this is a memory, and in memory, there is some value over here. There is some value over here, which is basically an address, which is basically an address, and this is being pointed by a variable called top. That's why it's called a pointer variable. It's called a pointer variable. On the other side, what do we have is called an array. This is also part of a memory only. It's also a part of a memory only. So now what do we do here actually? So we use the top pointer to access the array elements. Okay, but since it's a stack, we cannot access randomly. We have to use the prescribed method. That means from the top only you can access the value. Okay, so what do we say here? There is a value in the top, the value in the location where top is pointing. Top is pointing. Let's say this is 0, this is 1, and this is 2, 3, and 4. 3 and 4. So let's say this is loaded with the value 2. Loaded with the value 2. So now what are the max? Max will be, actually max is what here? It's a 15. So first we check if top is less than max. Top is less than max. That means what? The value pointed by top, because top is basically having a value 2. That is less than max. Obviously, that is less than a max. Then what do? We increment the value that is pointed by top by 1. Value that's pointed by top by 1. So what is the value that's pointed by top here? Now at this location, what is the value that's pointed here? It's earlier it was 2. So now this becomes 3. This becomes 3. Now where's the top here? The top is here. From here the top is moved. Then whatever the value that we have here, that will be moved to the place that is called a new stack of star top, that is pointer variable top. So what is the pointer value here? So top is pointing to the value 3. So to the stack of 3, the value will be loaded here. Value will be loaded here. Similarly, when you do it the next push operation, what will happen? Now this top will go to top will become 4. Top will become 4. Else if means what? The value pointed by the top is greater than max. Greater than max. That means what? The stack is overflowing, isn't it? So the stack is, we will say, stack is full. Stack is full. Then we can exit from the program. That is for the push operation. Next, what we have is a pop operation. Pop operation, what again? You see that here we have a array here. Okay, we have an array, and the array is having a index here 1, 2, 3, like this. Then again the same top pointer is used. Okay, so let's say now this is having a value 3. Having a value 3. So for a pop operation, what do we have to do? We have to check. And also this 3 is pointed by top. Again, it's a top is a pointer variable here. Okay, and this value is also, now one more thing is also there. That is another pointer here. Another pointer called val. Another pointer called val is being used. Okay, so val is also pointing to some value. It's going to point to some value here. We'll come to that later. So now first we check what are the condition of the top, because what do we have to check? Whether stack is underflowing. Is there any element to take it from the stack? So that how do we check? The value that's pointed by top, is it greater than or equal to 0? Greater than or equal to 0. So if you look into it, the value pointed by the top is what? Actually, it's a 3. So condition is satisfied. That means the top is already moved, isn't it? Top is already moved and we are somewhere in the stack. That basically, actually, if you look into it according to this program, this will be 14th location. So third is here only. Okay. So now the condition is satisfied. So if the condition is satisfied, next what we have to do, it's a pop operation. First we take the value out of the array. What is the value we'll take? So start top means what? The top is pointing to one location. It's a address now. So that where is the top is pointing? Top is pointing to 3. Top is pointing to 3. So from 3 we take the value. Okay, and again, whatever the value that we have taken from here, that we load it into the location that's pointed by value pointer. That's pointed by the val pointer. So that's what we do it here again by using the pointer. So the val pointer points to the fetched value. Okay. Next, what do? We decrement the pointer, the top pointer by 1, so that from 3 now it goes to 2. So that's basically the pop operation. So now here, by chance, the top is less than 0. That means what? Maybe minus 1. Got it? So if that is minus 1, then we say the stack is underflowing. Stack is underflowing. Then we say that the stack is empty. Values are not loaded here. So that's how the push and the pop operation is implemented. So next, the next thing is important part of the program, the main program. So in the main program, okay, so our array always it starts from 0. So what do? We initialize the top with to the value -1. Initialize the top to the value -1. Then new stack of now according to this program it is 15. Those are the size of the stack is what now? It's 15. Then locally we have two variables here. So that is n and value. Okay. So in the first part, what do we have here? Let us do this first. So we have there is a do while loop. Okay. So what this will do? First, it will display on the screen pushing element. First, we have to push the value onto the stack, right? So pushing element. So pushing element will wait for the user to give the value. Once the user gives the value will be taken and that will be given to the value variable. Next, push function is called here. What the push function will do now? Push function accepts the stack and also the current top address, then the value to be pushed onto the stack. Then next, what do? We ask the user whether you want to continue. So to continue, enter 1. Enter 1. So now user enters 1 or any value user can enter. By chance, if the value is equal to 1, whatever the value entered by the user is equal to 1, so that means the condition is satisfied. Condition is satisfied. Again, we continue to push the value onto the stack. So that's what is called a do while loop. So again, we continue to push the value onto the stack. So if the values, the one entered by the user is different other than 1, that means we are coming out of this condition is not satisfied. Then what do? We come out of this pushing operation. Now we enter into the pop operation. In the pop operation, again, what do? So in the pop operation, first we'll put it on the screen to pop enter 1. So again, what we'll do? We'll take the value from the user and we check whether value is equal to 1. If it is 1, as long as it is 1, what we'll do? We'll try to pop the function, pop the value from the stack by using the pop function. What the pop function will do? It accepts the stack over here and accepts the address of the top variable, and also it accepts the value of the address, and accordingly it will load the value from the stack. So after doing that, what it will do? It will print it on the screen. What is the value basically popped from the stack? What is the value popped from the stack? So that value will be printed on the screen. So after that, what will happen? There is a printf statement over here. So again, we will ask here whether to print the value. So to print the value, what it has to do? It has to take the value 1 from the user or any other value. So once the value is given here was a 1, let's say. So to continue, press we'll just give 1 over here. So after that, what will happen now? The condition will be checked here again. Condition will be checked here. Once the condition is satisfied, once 1 here, again this will continue. Otherwise, what will happen? It will come out of the loop and it will print on the screen. To continue, enter 1. To continue what? For what? Again the operation, to start from the beginning, pushing operation. To continue, enter 1. Then we take the value 1 from 1 or any value from the user. If it is 1, if it is 1, you see that here it's basically enclosed from here. From line number 37 to line number 59. So this is another do while loop. So again, if it is equal to 1, then it will start from here again. Again from line number 39, it will start. So this operation is going to continue over here. As it continue, we can push and pop the values out of the stack. Okay. Now let us run this program and check it out. So this is the program, what we have seen here. Now I'll just run the program according to the program. So when I run this program, I can see that it's asking for pushing an element. Okay, so I'm just giving now, I'm giving just 5. Then what it will do? It will ask me whether we want to continue to push operation. So then I'll enter 4. So not 4, I'll just enter 1 over here because I want to push couple of values. So again, 1 I entered. So pushing element I'm entering now. 6 I'll enter here. So again, it will ask me whether you want to continue with the pushing. Yes, I'll continue to push now. So then I will enter the value now 7 over here. Okay, so that we have entered. So now it's again asking whether you want to continue with the pushing operation. So this time I don't want to continue the push operation. I'll just come out. So how many values we have entered into the stack by now? By now we have entered 3 values, 5, 6, 7 are entered into the stack. So just now we come out of this pushing operation. Now it's asked whether you want to pop enter 1. Yes, I want to pop now. So if I enter pop now, which is the recently entered value, that is 8. So now you can see that it will say the value popped is, sorry, the 8 is not a value that's onto the stack. 8 is just be given just to stop the pushing operation. So what will be popped? It will be popping the 7 out of, that's the last one. The recent one, value popped will be 7. Again, it asks me whether to pop enter 1. So again, I'll continue. Then what will happen now? Which one will be popped? Yes, 6 will be popped. So if you want to continue the operation, we can do it. Otherwise, what we can do? We can give some value and we can come out of the program. So we want to continue again from the pushing. No, I don't want to continue. I'll just press 9 over here. And now we are out of the program. So that's how the stack can be implemented by using the array. It's a linear array itself. It's enough for us to implement a stack. Okay. Thank you. Thank you for watching.